can write this. Also, we can bring out the x because it's a constant here. We're integrating against theta only, not the x. And cosine theta squared becomes minus cosine 2 theta. No, cosine 2 theta plus 1 over 2. And if we integrate it, becomes sine 2 theta plus 2 theta over 4. And that gives you 2 pi gives you 1 over 2. No, pi over 2. But this is where I got stuck at first, trying to prove the Miles law. Well, isn't this the original intensity of the rays before it went through the polarizer? I thought about it and then realized I was wrong, because we have these rays in all directions, and the sum of all the directions is gonna be 2 pi all the way around the circle. So the original ray is x squared no, because we're only talking about this angle. And this angle, it's pi. And here we can see that the intensity has halved from what it was before using integration. If we were to think about it more intuitively, the vertical magnitude of this ray is slightly less than a full amplitude, and when it's 45 degrees, the cosine theta squared is root 2 over 2, square the whole thing, is 1 over 2, a half. And here, when it's perfectly perpendicular to the polarizer, the intensity is 0. So on average, which is what we see right here, the intensity is halved. So there you go, we have proved the Malus law using integration. Hopefully this won't help you solve problems more quickly, but you will feel more comfortable using the law because you know why it works instead of just taking what your teacher says to you for what it is, but actually thinking critically and coming up with a more rigorous and mathematical explanation for the law. Thanks for listening. If you have any questions, leave comments in the comment section. I will try to answer each individual questions with a whole video dedicated